Welcome back to January 7th LeetCode Challenge. Linked list random node. Given a singly linked list, return a random node's value from the linked list. Each node must have the same probability of being chosen. So I'll implement the solutions class, where solution takes in a list node called head and initialize the object with the integer array nums, as seen right here. There's something called get a function called getRandom, which returns an integer. Choose a node randomly from the list, returns its value. All the nodes of the list should be equally likely to be chosen. So let's look at example number 1 here. Well, actually, yeah, example 1, we have linked list of 1 connected to 2 connected to 3, as given by this input parameter as such. And we're calling the function solution, and then get random 1, 2, 3, 4, 5 times. And then here's the output. Obviously, get solutions class returns nothing because it's the solutions. And then get random, choose the random number from the linked list, and I called it here. So the order of the numbers do differ from time to time, I would expect. And then yeah, so because it's getting a random number. So the important aspect of this, each element should have equal probability of being chosen return. So that's an important aspect there. Excuse me. The number of nodes in the linked list in the range is between 1 to 10 to the 4. Each value of the node between negative 10 to the 4 to positive 10 to the 4. At most 10 to the 4 calls to make to get random. Alright, so here's some follow-up questions. What if the linked list is extremely large? The length of the length that's unknown to you. If you can solve it efficiently without using extra space. Let's see if we can aim for this right away. I was perusing this question a bit earlier and noticed that there's a familiar algorithm on there that will help me solve this. So this is one of the class building type of question. So in order to kind of solve this, you kind of need the aspect here to be equally likely to be chosen, which calls for the getRandom function to be randomly chosen, right? And what calls to mind when that happens is that you want to do to randomly sample over a population of unknown size, right? And in constant space. So the solution to that is using a reservoir sampling algorithm, which is developed by there's a family of algorithms, but it's an algorithm. It's an algorithm that you need kind of two things to be fulfilled. I'm just gonna write down some notes here actually. It's called the Reservoir sampling algorithm. It's a family of algorithms that that you kind of need two things to make it happen. So the Reservoir sampling algorithm is intended to sample k elements. So you don't sample k elements from a population of unknown size, and in our case we just happen to have a population of unknown size of size k. Excellent. So there is the reservoir sampling algorithm is a family algorithm. Specifically, the one we're going to use is called algorithm R by Alan Waterman, and there's a bunch of other names for it as well, but there's different types of styles of it. But the algorithm R is optimized for the solution, giving us without using extra space. I'll drop a link to the Wikipedia page below on algorithm R. So there's some pseudocode for it I can go over, but ideally what we want is we have a reservoir, which is our singly linked list of size k of unknown size. Of length of unknown length. So what we want to do is basically take the probability to get a randomly chosen element out of this linked list. So what we could do is we could pool all the linked list elements together and just basically take one element out randomly, right? And not take it out, but just return it, because we need to rebuild and return it again later. So that's how the gist of it goes. So let's summarize that a little bit. So initially, we want to fill up the reservoir, as we call it, with all the elements of the head elements in the node from our pool that we need to sample from. And at the end of the algorithm, we want to have it contained with all the final elements that we can sample for a pool. Then what we want to do is iterate through the rest of the elements. And then we need to decide to whether we include in the reservoir or not. So then we just replace the existing element in the reservoir with the current element, and then we just kind of iterate through our pool. So the important thing is that you need to know that how do we ensure an equal probability to be chosen. So because we need to know that the restrictions of the question is asking that given the above algorithm, we just guarantee that each moment in time for each element scanned so far has an equal chance of being selected into the reservoir. So there's a bunch of math to it as well, but ideally what we want to do is implement that. And how do we do that? So the first thing we do is a init function. We just want to keep it for simply our head. So rather convert to an array, we just keep it as head. So we do self.head equals head, or assigned to head. Alright, so to get random algorithm, so what we want to do is we want to perform the reservoir sampling algorithm from the head of the linked list. So what we want to do is scan the elements one by one and decide whether we put it into the reservoir or not. And let's do that. So the size of it, so we have what's called one pool that we need to deal with, right? So we have one reservoir to choose from, and that means we have one linked list. That's our scope. And our chosen value is currently 0. I'm going to just say value chosen is going to be assigned to 0 because we haven't chosen anything yet. And we're just going to call a current node to be self.head. So the algorithm starts off whether we want to decide whether we want to include the element in the reservoir. So what we want to do is do a while loop while current is equal to head, or exists, I should say. We want to decide if, so we actually call the random function random. If that's less than 1 over the scope, right, and the scope is actually equal to 1, so it's less than 1, then we want the chosen value to be assigned to the current value. And then we move on to the next. We iterate through the next element. So we move on to the next node, so current. So that will be the typical current equals current.next. Given here, right? We have current val, current next, and then we want to increase our scope by 1. So this is the implementing the reservoir algorithm, and then we want to return our chosen value. Alright, let's see if this works in any way. Well then, obviously the numbers are different. I'm hoping this works. Wow, it works. Awesome. So I'm guessing the testing algorithm behind the scenes is doing a random population distribution type of comparison. It's not the fastest algorithm, but in terms of memory, it is. Let's kind of go over it. Time complexity wise, this is constant time. Random is linear time, it's big O of n, because we have a while loop here going through each element, where n is the number of elements of inputs in the list. Space complexity, however, it's constant space, because the overall solution, since the variables we use in the algorithm are of constant size, regardless of the input. Alright, there you go. Reservoir algorithm. Take care, guys.